Hello and welcome back. In this lesson, we are going to focus on VPC network routing basics, specifically the Internet Gateway, routing tables, and subnets. These are key components of the VPC and are all required to have successful routing in and out of the VPC. So again, let's just recap what's going on here with this diagram. We have our customers and our AWS users, and they can both be accessing resources in our VPC like EC2 instances or RDS databases. And what I'm showing here is how the data from each one of these users will flow into the VPC, the components that it will go through in order to reach the EC2 instance or the RDS instance. So let's start with the Internet Gateway because this is the first access point for data coming in to your own private VPC. So over here, we find our Internet Gateway by clicking on Internet Gateways here. And as with the default VPC, which we talked about in the previous lesson, there is an Internet Gateway that is already created and attached for us. But let's dive into the Internet Gateway here and talk a little bit more specifically about what it is. So an Internet Gateway is a VPC component that allows communication between instances in your VPC and the Internet. It is horizontally scaled, redundant, and highly available. It imposes no availability risk or bandwidth constraints on your network traffic. So what do those last 2 points mean? It just means that AWS is managing all of the back end for the Internet Gateway for us, and it will grow or shrink elasticity depending on how much traffic we send through it at any given time. So we don't have to manage its bandwidth, its capacity. AWS does that for us, and if the Internet Gateway fails, it automatically replaces it for us. So there's also built-in fault tolerance. It also provides NAT translation for instances that have a public IP address assigned, meaning public IP address to private IP address. And as I mentioned before, just a quick note that your default VPC already has an Internet Gateway attached, which we see here. Some Internet Gateway rules and details that you should definitely know is that you can only have one Internet Gateway attached to a VPC at a time. So this Internet Gateway here, here's the Internet Gateway ID number, is attached to this VPC here. We can see the VPC ID ending in 3380. And if we go back to the VPCs, we'll see that our only other VPC is the VPC ID that ends in 3380. So that's how we tell which VPC an Internet Gateway is attached to. Next, an Internet Gateway cannot be detached from a VPC while there are active AWS resources in the VPC, such as an EC2 instance or an RDS database. So if I had an RDS or an EC2 instance provisioned and inside of this VPC, then I wouldn't be able to select this Internet Gateway and detach it from the VPC. But because I currently don't have any resources in the VPC, I was able to detach it. In this case, if there was a different VPC, I could attach it to that VPC, assuming that VPC didn't have an Internet Gateway already attached, because again, you can only have one Internet Gateway attached to a VPC at any given time. So let's go ahead and reattach this. Also, an Internet Gateway must be attached to a VPC if the resources inside the VPC need to connect to resources via the open internet. So just taking a look back at this diagram here, if we have an EC2 instance, perhaps that's hosting a web application or a website, and it's serving traffic out to customers across the open internet. If I were to come in here and detach an Internet Gateway. Now, I can't detach it if there's resources inside, but let's just say that an Internet Gateway was not there. I never created it. Then there would be no way for traffic to come into the VPC or to exit the VPC. So an Internet Gateway must always be attached to a VPC if there's going to be any transmission of data in and out of the VPC. Very important. Next, let's talk specifically about route tables. So in route tables can also be found over here by clicking on route tables. And as with the default VPC, we already have a main route table that is created associated with the VPC and also has several subnets already associated with it, but not explicitly associated with it. And I'll cover that in a minute. But let's talk about specifically what a route table is. So a route table contains a set of rules called routes that are used to determine where network traffic is directed. And this is the Amazon Web Services definition. A route table's rules are comprised of two main components, one being the destination and the other being the target. Now, the destination is the CIDR block range of the target where data is being routed to. And the target is a name identifier of where the data is being routed to as well. So if we take a look over here at our route table, if I click on it, down here under routes, we can see the current route table and the destination and the targets that are associated with it. So when we look at what is here in the default route table, we see a target of local, and I'll explain what that means in a second, with the CIDR block range, and then also a target of, if we look here, it says IGW, stands for Internet Gateway, with a CIDR block range of 0.0.0/0, meaning any destination that traffic can be sent to. So let's just take a quick look back at our diagram here. And so what's happening here is that the route table, again, is what is directing traffic with inside of our VPC. So what happens is when a packet of data comes in, say from a customer, and it has an identifier that says, I need to go to the IP address associated with this EC2 instance. Well, it comes in across the open internet through the internet gateway, and it hits the route table. And the route table says to the packet, hey, where are you going? And it says, I'm going to this IP address. And it's then going to direct it or route that traffic to the correct IP address or to the correct EC2 instance within the VPC. So when information comes in to the VPC, it is handled by the route table and passed to the proper location. But then also when information is sent out from an EC2 instance back out to the route table through the internet gateway and to the customer, that routing initially inside the VPC is also handled by the route table. So what the designation here, or the target of the internet gateway, is it's saying is that it is giving the route table, or is giving the VPC, or more specifically this subnet that's associated with it, a route to the open internet. So it is saying, hey, you have a possibility, you have this route to the internet gateway. You can send traffic to the internet gateway, which can then direct traffic out to the open internet. So that is what's going on here with the internet gateway as a target and a destination of 0.0.0.0. It's just saying that it can go anywhere it likes to out on the open internet. There's no restrictions to traffic going out. What it means here by local is we're talking about routing internally within the VPC from subnet to subnet. So if we look here, we see these red lines. These red lines represent our local, or our traffic that is routed internally. So what can happen, and this can happen without an internet gateway, is that traffic from this EC2 instance can be routed internally to this EC2 instance, or traffic from this RDS instance can be routed to this EC2 instance. And that's what's done here through the local target, and the designation here, this is the CIDR block range of the VPC. So continuing on with our explanation of route tables, by default, all subnets traffic is allowed to each other available subnet within your VPC, which is called the local route. That's what I was just describing. And one of the things that we have to understand is that we cannot modify this local route. So if I click on edit, we'll see here that I'll be able to edit and change or delete the internet gateway, but I cannot edit or change the local target. Also, unlike an internet gateway, you can have multiple active route tables in a VPC. And if we look at the diagram here, you will see that I have two route tables, and I'm going to talk specifically in a minute what these two different types are and what their purposes are. Next, you cannot delete a route table if it has dependencies, so associated subnets. So very much like an internet gateway cannot be detached from a VPC if there's resources inside the VPC that are currently using it. If you have subnets that are associated with a route table, then you can't delete the route table until you remove those dependencies. So, best practice, we come back to that term again. Best practice is to leave the default route table and create a new route table when new routes are needed for specific subnets. So basically, if we wanted to add subnets or create some new routes within our VPC, best practice is to not alter the default one, but to create a new route table and then designate those routes on that new route table. So that's a quick summary of what route tables are, and we're going to come back and tie this all together once we're done talking about subnets, but let's jump in and talk about what subnets are now. So over here in the console, I will click on subnets. And as we see here, as data flows in from either our users or the customers through the internet gateway, hits the route table, and say we're to get routed to this EC2 instance, it would have to now enter this subnet. Now, let's talk a little bit about specifically what subnets are. So when you create a VPC, the VPC spans all of the availability zones in a region. But after creating a VPC, you can add one or more subnets in each availability zone. Each subnet must reside entirely within one availability zone and cannot span zones. So again, if we take a look here, the way that I've set up the diagram, this subnet here is entirely within this one availability zone. This subnet, subnet 2, is entirely within this availability zone. So just something important to understand is that VPCs span availability zones, but subnets have to be contained within a specific availability zone. Next, subnets must be associated with a route table. It's just something that's required when you create a new subnet. Next, now we're going to talk about the difference between public and private subnets, and this is something that's very, very important to understand. A public subnet has a route to the internet, meaning that it is associated with a route table that has an internet gateway attached. A private subnet does not have a route to the internet, meaning that it is associated with a route table that does not have an internet gateway attached. So let's back out here now and look at these two route tables that I have in our diagram. I have a route table with an internet gateway attached and a route table without an internet gateway attached. So the route table with the internet gateway attached is what allows traffic to come into our subnet 1 public and our subnet 2 public, because both of these in my theoretical diagram here are associated with this route table, and this route table has an internet gateway attached, which if you remember, we click over here and we see this route table with an internet gateway attached to it. These two subnets down here, which I've labeled subnet 3 private and subnet 4 private, are associated with a route table that does not have an internet gateway attached. And so this means that traffic cannot be served from the open internet to either one of these two instances, and traffic originating from one of these two instances cannot be routed back out to the open internet. But remember, using the local target, they can communicate with each other internally. So just to show you what that would look like, if I were to create a route table here, I can call this private route table. When I first create this route table, we see that it only has the target of local and the destination of the CIDR block range of the VPC. So both of these route tables both have the same local, meaning that they can share information or send data amongst themselves between the public and the private subnets, but any subnets associated with the private route table, because it does not have an internet gateway attached, would not be able to serve traffic out to the internet or receive traffic from the internet. So these are very important concepts to understand when it comes to VPC networking and routing. So instances launched into a private subnet can't communicate with the internet. We just covered that. But this does two things. One, it creates a higher level of security because nobody outside of the VPC could access those instances. However, there are limitations because the instance will not be able to download software and/or updates. However, this issue is solved by routing through a NAT instance. Now, these next 2 points I've already covered, but we'll just recap them one more time. And it is, again, just by default, all subnet traffic is allowed to each other available subnet via the local target in the route table. And again, we covered that also in the route table section, which we just talked about a few minutes ago. And a subnet is located, again, in one specific availability zone and does not span availability zones. Very important to remember. Now, when we talk about associating subnets with a route table, it's important to understand that with route tables, you have explicit associations, but then you also have non-explicit associations. So on the default route table, all of the subnets are non-explicitly associated with the default route table. So we see here explicit associations is 0 for the default route table. However, I can decide to, say, take 2 of these and explicitly associate them with this particular route table. And then if I wanted to take our other 2 subnets, I could then explicitly associate them with the private route table. So now what I've done with these two subnets here is, in essence, I've made these two subnets private because they are now no longer associated with the default route table, which has the internet gateway attached. They are now associated with the private route table that does not have the internet gateway attached. So again, just like this is set up here in the diagram, we have one route table with two subnets that are associated with a route table with an internet gateway, and that's represented here by this default route table with the internet gateway attached. And then I have two subnets that are associated with a route table that does not have an internet gateway. See, no internet gateway here, and therefore that makes them private subnets. So just to recap, we've talked about internet gateway, route tables, both public and private, and subnets. And hopefully through that explanation, you start to get a good understanding of how routing occurs into and out of the AWS VPC, and then also where to find, access, and look at those components here in the AWS console. Next, we're going to move on to VPC security, where we're going to talk about network access control lists and security groups. But for now, that will complete this lesson. Thank you for watching. You may now move on.